Hey guys, just got this in. This is the brand new SOK 12 volt lithium iron phosphate battery. This is their new 280 amp hour version that's over 3,500 watt hours of stored power. This battery is capable of 120 amps continuous charge current and 200 amps of continuous discharge current. This also features their new version 8 of their custom designed BMS with a few additional bells and whistles. One of those being that the balancing current has been increased to 120 milliamps. The other being that it will now balance continuously as long as there's a charger connected until the cells are within 20 millivolts of each other. Both of those features will help the cells in your battery remain balanced so you see the full capacity when you need it most. Additionally, this battery can be used in cold climates down to about 4 degrees Fahrenheit as it has built-in heating functionality. So that's enough talking, let's get down to it. We're going to do a quick overview of the external characteristics of the battery. We'll do a capacity test, and then our favorite part, we'll tear it apart and see how it's built inside. This battery measures 13 inches across, 9.5 inches in depth, and 9.8 inches in height. Additionally, it weighs in at 73 pounds. It's quite a heavy battery with those 280 amp hour cells. We've got our standard terminals here that we've seen on most of the SOK batteries at this point. They are M8 bolts, and they're quite lengthy M8 bolts too, which is good in case you need to fit 2 or 3 lugs on here. On the top here, we have our collapsible handles, and then we have what appears to be a pressure vent. The manual that comes with this battery is very basic high-level information. Honestly, I feel like it's quite a bit lacking. There's not even a list of specifications in here. There's a little information on the BMS, there's some information on your series and parallel connections, but other than that, there's not too much to see, and there's a lot of room for improvement, I think. So I wouldn't spend too much time on the manual, and I would instead download the datasheet from the SOK website. This provides all the technical information I think you'll need. Like we said, it's 280, I guess that's supposed to be amp hours there. 3,584 watt hours. Max charge current recommended is 56 amps. Our voltage parameters, max continuous discharge is 200 amps. And then we have our temperature and BMS characteristics here as well. The SOK has been charged up using my AIMS 12 volt lithium iron phosphate rated charger, and I did leave this charger connected overnight, so it's hopefully done a little bit of balancing. I have my usual capacity testing setup connected, a 12 volt inverter. I've got a Batrium shunt in my display. We can see on the bottom here discharged amp hours and discharged watt hours. And my test load is the AIMS 48 volt charger going back to my server rack batteries. So we're sitting around a 982 watt load. That's approximately 75 amps at the current voltage. Gonna leave this run until the BMS and the battery shuts down our test, and we'll see what our measured capacity is. All right, so the final countdown is beginning here. We're at 284 amp hours so far, and the voltage is starting to drop. And there we go. It has shut down. The BMS in our test has shut down. The final capacity is 291 amp hours there. And you'll notice down here in the lower right, I have a fan blowing into my inverter. I think this is going to be the end of life for the Best Tech inverter. It was getting very hot throughout this test, and I don't know if the fan inside seized up or what the deal is, but now you see how easy it was to remove this lid, and this is pretty cool because their previous batteries, what you'd have to do is bend the lid up a little bit and try to unscrew some conductors under there because the terminals are on the top. So this makes it very easy to remove and service this battery. And by the way, these batteries are designed to be serviceable. They're designed for ease of swapping this BMS out should you ever need to. All right, that's not the BMS. I was expecting to see the BMS under here, but now I see the BMS is actually down here in the side. So the first thing I notice when I look at this battery are the sheer number of bolts going across the top and the bottom here. It appears this board on top here is simply a way to easily get the balance leads off of the battery. And these are 10mm bolts. And with those all removed, I should, be able to pull this up and tilt it to the side. So that is a PCB or a printed circuit board. And you can see the layout here of the traces and how that's done. This is actually a very neat idea. So removing that has made visible 2 additional components. We have a thermal switch here. This thermal switch is rated for 55 degrees Celsius, so this is likely going to be an over temperature protection. And then over here we have a standard temperature sensor or thermistor, and this is likely going to be for the low temperature protection along with the heater control system. All right, so down in here at the BMS, I'm going to remove this white connector, which are the balance leads going back to that printed circuit board. And I'm also going to detach this red connector here, which is also coming from the printed circuit board, and that's providing positive power to the BMS. So I can safely pull up the BMS with these two terminals here. However, there are a number of leads still connected to the BMS. That is both temperature sensors and then this red heater lead down here. So now on the side there we can see our connection points for the thermal switch and for the heater pad. So we can go ahead and disconnect both of those. Actually, the thermal switch does not disconnect, so we'll have to pull that off of the batteries here. All right, there's the BMS. And here we have our BMS. This is model number SK4S120. So I went ahead and removed the mounting plate here from the bottom. See, there's a very large thermal pad there. It is interesting though that they have this plastic between the thermal pad and the metal plate, as that's going to kind of act as an insulator. But I guess most of that heat is being dissipated on this top piece here, and that's quite a bit thick. Look how thick that is. Does this come apart any further? Oh, yes it does. And here's a closer look at the BMS board. There's not a whole lot to see like usual on some of these anymore. We have our charge and discharge controlling transistors here, the MOSFETs. This is probably the computer circuit up here controlling the whole thing. We have our balance leads coming in here. We have 4 resistors and 4 transistors controlling these resistors. These are the resistors that are going to turn on to bleed off some of the power to help get your cells balanced. We have an additional temperature sensor here, which is coming down the center in the middle of the heatsink area. That's good to see as well. This section down here is going to be control for the heater pads. So we can see the 2 transistors that turn that on and off. Next, to remove the battery pack, there are 3, 6, 9, 12 Phillips screws holding this entire thing in. Ah, there are the cells. Okay. On the bottom of this case, the cells are enclosed in. There are 3 Phillips screws on each side. Let's see. Oh, they're in this bottom tray yet here. Man, there's a lot of layers to this. It's like an onion. Oh, I see. Okay, they just slide out like that. Okay. So here's the bottom tray. This is very light. It is metal. It feels like brushed aluminum. All right, taking a look at our cells, they should just pull apart. There we go. The plastic casings pull off here. And new cells always look beautiful. It's this pristine blue look. And for some reason, this blue seems to fade over time. It just never looks the same after it's sat, built in a battery pack for a number of years. Looking at the top of the cell here, they have a very nice aluminum terminal block laser welded to the cell. You can see the laser welds there, which allows us 2 bolt holes here for securing the bus bars. This is a very similar design to the EVE LF280K cells, I think it's the K cells, where they have this large aluminum block laser welded to the cell. And here's a closer look at the pressure vent and the QR code there. These do look like brand new cells. They appear pristine in every way. I don't see a single dent, scrape, scratch, ding, or anything on them. Now, I did reach out to both SOK and Current Connected because I couldn't figure out what brand cells these were. In most SOK batteries we have reviewed, we see GFB cells. Both SOK and Current Connected did inform me that the initial version of this battery does include ETC brand cells, and that ETC is pretty much near identical to GFB. The reason for that was due to availability from GFB for the cells and the lead time required to order cells. So Min from SOK did tell me that they signed a purchase agreement from GFB going forward. However, the initial version of this battery at launch will have ETC branded cells. And here we can see the heater pad sandwiched between 2 cells. This battery has 2 heater pads, one between cells 1 and 2, and then one between cells 3 and 4. And this heater pad is stuck to the cell, but it's not stuck in a permanent way, such that if you ever needed to replace a cell for any reason, you can see I'm able to pull it off and then just simply stick it back on your new cell. And there we go, it's put back together. It's that easy. I love that they have designed this with serviceability in mind. Of course, hopefully you're not having to service your battery. I don't think most people will have to service their battery. These are the bus bars used on these cells. They are rigid pieces of metal. They do have a fair amount of mass to them. I think 200 amps is probably where I'd stop, which is the rating of this battery. They are not aluminum. They are some sort of, I did file the corner of this one back here. I don't know if you can see it. It does have a very slight copper color. I seem to remember they were using some sort of was it copper nickel alloy or something? It was some sort of copper alloy. So they are not aluminum, but they are also not pure copper. But they are pretty good bus bars. We're going to go ahead and get this put back together, and then we'll do some temperature testing. All right, so now we're going to test the low temp charge protection and the heater functionality. We have here the temperature sensor or the thermistor, and I've got a clamp meter on the positive lead. I'm going to turn on the charger, and then I'm going to spray this temperature sensor with some computer duster here. which should drop this well below freezing, and we should see that heater circuit engage. What I'm expecting to happen is to see the charge current drop to about 7 to 8 amps, which will indicate that it's now powering the heater instead of charging the battery. And we're charging at approximately 77 to 78 amps. Let's go ahead and chill our sensor. And that was 4 seconds. In 4 seconds, you saw it drop down to 0, and now it's on 9.3. So now that charger is powering the heater and the battery is not charging. And as soon as this sensor warms back up, we should see it resume normal charging again. I'm gonna go ahead and use this glove so I'm not touching it directly. All right, and there we go. We're back to 79 amps. So let's try this once more, and I'm gonna count the number of seconds. 1, 2, 3, 4. 4 seconds again. So we can say that the low temperature charge protection and the heating functionality on this battery does work. And lastly, a very quick look at the BMS. This is the ABC BMS app from the Google Play Store. I assume it's the same on iPhone, but I don't have an iPhone myself. We can see here the state of charge. We can see the charge and discharge MOSFET status. Voltage, current, calculated capacity, it's saying is 285 amp hours. Interestingly, it's showing 0 cycles. I did do a full charge and discharge of it, so I'm not sure why that hasn't incremented to 1 yet. Perhaps it doesn't increment until I complete another charge, I'm not sure. We can see indicators for the protection status, that's over or under voltage protection, discharge protection, things like that. And then we also see an indicator for balancing status and the voltage differential. We're sitting at a difference of 0.017 volts per cell. And then lastly, we can see the voltages of all 4 cells there at the bottom. There's a separate tab that shows the protection state, and this shows specifically which conditions have been hit that triggered the protection mode if you need to check that. There's not a whole lot to see on the app here, but it is something that's very handy to have available. There are a couple of additional things to keep in mind about this new 280 amp hour battery. The first being, these are delivered in a sleep state. That means it will arrive with the BMS shut down to prevent that BMS from discharging the battery while it's in storage at the warehouse, while it's in transit, and while it may be in storage at your location. You will see 0 volts across these terminals, and to wake this battery up for the first time, you simply need to apply any 12 volt charger. All it needs to do is see 12 volts on these terminals to turn that BMS on and begin charging. You can use any kind of lithium iron phosphate based charger, or if you've got a bench power supply like this, that works very well. But I say that because I know there are people out there who receive these and they're like, hey, why isn't my battery working? Well, it's in a sleep state. Number 2, these batteries can be wired in series for up to a 48 volt configuration. And that's great and all, however, I personally would not do that with a heated battery, or even at this point, any 12 volt battery. It makes more sense to me that if you need a 48 volt battery to go out and purchase a 48 volt battery, instead of trying to series multiple 12 volts and hoping those 12 volts remain in balance. Theoretically, if you balance them correctly up front, they should remain in balance throughout the lifespan of the battery. These batteries that have heaters built in have an additional intricacy, and that is that if you have 4 of these batteries lined up in series, they don't have any way to communicate with one another. So for example, the heater in battery 1 could turn on, but it's not going to turn on at the same time as the heaters in batteries 2, 3, and 4. So it's possible for some batteries in your series string to be charging and other batteries to be running the heater. So they're going to quickly throw themselves out of balance. For that reason, while SOK supports seriesing these batteries together, they recommend you only do it if you're going to apply a battery balancer to balance each 12 volt battery out. Now, if you're going to do that, just go and buy the 48 volt battery. Because the amount you're going to spend on 4 of these batteries anyway, you're going to get more capacity and save money going with multiple server rack batteries versus trying to series the 280 amp hour batteries. Now, all of that said, there is one thing I do not like about this battery. And that is the bottom of this battery has screws, the same as the top, that protrude out the bottom of the battery. So whatever surface you set this battery on, these screws are totally going to chew up that surface as you slide it around, especially if that surface is wood. And if you set it on metal, you're going to end up with scratches as well. I don't know why they couldn't countersink these screws, but if you're going to get one of these, I would definitely set it on some plastic or some sort of rubber mat. Other than that, I think this battery is built exceedingly well. It's the same consistent quality we get out of SOK. I love the fact that it's serviceable. It's very easy to take apart and replace parts if needed. And I also think they're spot on with the price point. Now, for the time being, these are only available from SOK directly. Now, I did ask Current Connected, and they told me they do plan to carry 280 amp hour batteries in the future. However, their version of the SOK 280 amp hour will not include that heater. Otherwise, it's been a long week of fooling around with batteries, and I'm very much looking forward to getting back to working on my car. I need to figure out why this 1ZZ engine has a shake to it. So that's what I'll be doing the rest of the weekend here. Questions or comments, you can leave those. Hit that like button before you go, and thanks for watching.